Get the phone! Thank you. Hey, Unit 2, Topic A, adding, subtracting, rational numbers. Woohoo! So, vocabulary is abundant here at the beginning. Lots of new features and vocabulary words that you will see throughout your mathematical career. So, let's get into it here. Here we go. Lesson 1, identifying the number system. Okay, let's go through these guys here. You got a little bit of a visual of what's going on. I'm going to slide into and start filling some of these. So, instead of just jumping into the definition, we're going to get some examples first. So, whole numbers. These are the numbers you were born and raised with as a little child. Ask them to count. 1, 2, 3, 4. That's exactly what we are dealing with here. So we'll fill some of those in. A 1, a 2, a 3, a 4, ... Okay, whatever there. So that's what we're talking about regarding whole numbers. Non-examples, let's not talk about that right now, okay? So regarding like a mathematical definition, like, I'm not going to get into with whole numbers there. Like, let's just leave it at that. Sometimes they call them counting numbers. I mean, you can say numbers without a decimal or a but hey, I think we're trying. These are the guys we're interested in. Integers. All right, so here we go. Integers here are your positive or negative whole numbers. So the idea here is, hey, not only do we have 1, 2, 3, 4, but we continue the number line going the other direction. So 0 is also an integer, and then -1, -2, -3, -4, so on and so forth there. So if you are an integer, you are a whole number. So no decimals, no fractions, all right? But you could be positive, you could be negative. So the number 3 is a whole number, and it's also an integer. All right? Rational numbers. Okay. Again, vocabulary words you will hear. All right? These stay with you throughout high school. Rational numbers. This can be any number written as a fraction. So if we can write it as a fraction, it is a rational number. So we talk about examples here. Any number, 7, over any number, -3. We've got ourselves a rational number. Okay, so 3. Can you write the number 3 as a fraction? Sure. 3 over 1. Man, the 3's don't show up nicely. So anything written as a fraction. How about this? Can you write that as a fraction? Yeah, 4.5. So decimals are rational numbers. So 7.1. All right. -2.38. So a rational number just needs to be able to be written as a fraction. So that means all decimals can be written as a fraction. Now, we're going to get in one little loophole here. I'm not going to spend a lot of time on it because, well, you haven't really seen them before. And you won't see them for a few years down the road. We really don't deal with them here. And that's what's called an irrational number. So an irrational number is a number that cannot be written as a fraction. All right? And it's a decimal that goes on forever, but no pattern. You see, because repeating decimals can be written as a fraction. So what is that? Well, your only experience is with pi. And pi is that relationship of the diameter and the circumference of a circle. Yeah, like I said, not a lot. Some of you might have memorized how many digits in elementary school. Okay. But yeah, we don't deal with them. So we're not really going to talk about them. Our main focus there are your integers and your rational numbers. And again, understanding what a whole number is, I think we're pretty straightforward with that. Okay, so let's go into this here a little bit more. Rational number, a number that can be written as a quotient. Okay, quotient. Quotient means to divide. What's the symbol we use for a... I'm sorry. What symbol do we use to show division? Well, we use a fraction bar. All right, so that means 8 divided by 4. A fraction bar means to divide. So we do want to keep that in mind. So a number that can be written as the quotient of two integers is also known as a rational number. Okay, the denominator cannot be 0. A terminating decimal is a decimal that stops. Okay, a repeating decimal, all right, that is a decimal. The repeating pattern goes on forever. So terminating decimal, 4.8. All right, repeating decimal, 3.72, and something repeats. So keep that in mind. That's just something to kind of be aware of. Let's see who else is there. Is it terminating repeating? And yes, it's rational. Let's see if there's anyone else in there. Yeah. So we'll be jumping in this in class together. But the main thing here is we want to start understanding that some of them are the same. So like we said, we can write them in numerous ways. So are you good with your vocabulary? Like I said, it's just stuff that we'll hear over and over again. Oh, the clowns are back. I gotta go, people. We'll talk in class tomorrow.